One day in physics during 7th period, Olivia, Edie, KeLee, and Nicole had to ask Mr. Drexel a question.
They didn't feel like getting up, so they decided they would throw a ball at him to get his attention.
They didn't know which ball would get his attention the fastest, so they decided to test it out.
Trial 1, tennis ball. We're trying to find velocity, so we're going to use the equation velocity equals distance over time. Our given distance is 4.33 meters and our given time is 0.8 seconds. So we did 4.33 meters divided by 0.8 seconds, and we got 5.416 meters per second. So now we're going to find the acceleration for the tennis ball. So we're going to use the equation A equals final velocity minus initial velocity divided by time. Our initial velocity is 0 meters per second, our final velocity is 5.416 meters per second, and our time is 0.8 seconds. So we did 5.416 meters per second minus 0 meters per second divided by 0.8 seconds. And we got 6.77 meters per second squared.
Trial 2, soccer ball. So we're trying to find the velocity of the soccer ball, so we use the equation distance divided by time. And the distance was 4.33 meters and the time was 0.842 seconds. So we did 4.33 meters divided by 0.842 seconds, and we got 5.146 meters per second. So we're going to be finding the acceleration of the soccer ball, so we're going to use the equation the final velocity minus the initial velocity divided by time. Our initial velocity is 0 meters per second, our final velocity is 5.146 meters per second, and our time is 0.842 seconds. So we did 5.146 meters per second minus 0 meters per second divided by 0.842 seconds. And we got 6.112 meters per second squared.
Trial 3, volleyball. To find the velocity of the volleyball, we use the equation V equals distance over time. Our givens are D, distance equals 4.33 meters, and T, time equals 0.9 seconds. V equals 4.33 meters divided by 0.9 seconds, and our velocity is 4.814 meters per second. To find the acceleration of the volleyball, we use the equation A equals final velocity minus initial velocity divided by time. Our givens, the initial velocity is 0 meters per second. Our final velocity is 4.814 meters per second, and our time is 0.9 seconds. Our equation is A equals 4.814 meters per second minus 0 meters per second divided by 0.9 seconds. Our final acceleration is 5.349 meters per second squared.
After multiple calculations, evaluations, and arguments, the students decided to throw a tennis ball. Its velocity and acceleration exceeded their expectations, and from then on, Mr. Drexel carried a tennis racket with him everywhere he went.